we are going to understand an important concept in calculus, the nature of a stationary point. In this topic, it is very important part in exam. So focus on both idea and of course, this idea can give you a very good success in your exam. A stationary point occurs when the gradient or the slope of any curve, so any equation or any curve, the slope can be defined as dy, y say a function or a curve, dx is equals to 0. If these satisfy, you can say that the function or the curve has a stationary point, right? In the blue curve, the flat region or the flat line represent the stationary point of inflection, and when we look on the orange curve, this is the point we have got the maximum point, and down here is the minimum point, right? Now we are going to describe when it is minimum, when it is maximum. Let's try right now. The point of stationary, it actually represents that the graph is flat. As I mentioned, it means that at this point, what is happening? No increase and no decrease. At this point, I mean, where the exact point? Say here, actually, the value of x is equals to 1. Just an example, actually, or any point. At that point, there is no increase and no decrease, and it's look like a flat line or flat graph, right? 0 doesn't tell us everything. We need to determine the nature of that stationary point. Indeed, there are actually 3 possibilities. Very first point, imagine climbing a hill, you go up, reach the top, then down. It means a slope before it was positive and after it is negative. The condition, of course, the second order differentiation, so d square y over dx square is equals to 0, and of course the curve is bending downward, right? So it should be look like this. So it is bending downward. Earlier of the slope, it is positive, and afterward it will be negative, and this point the maximum point, right? And point number 2, now you need to think that there is a valley, right? We need to go down, reach bottom, then go up. So it's look like this. So at this slope, before it's need to be negative and afterward it will be positive, and this is the stationary point, right? And of course the condition complying the second order differentiation d square y over dx square is greater than 0. The curve is bending upward. Of course, in that case, we can say this is the minimum point. So this figure complying this one, and this figure complying actually this one, the maximum and the minimum point. The third point, we can say the point of inflection, the point of inflection. It is actually a special case. Sometimes the graph flattens but doesn't turn. We need to keep going in a same general direction, and there might be a curvature of change. Which condition? The condition, the second order differentiation d square y over dx square, it should be equals to 0. Here we actually made a big mistake that it will be actually less than 0. So when it is less than 0, we have maximum value, and when it is greater than, we have got the minimum value. When we have got the second order differentiation d square y dx square is equals to 0, in that case we have to check again. It means that we have to differentiate third order as well, so d cube y over dx cube, and if it is not equals to 0, in that case we can say the point is inflection. And of course we will have 3 different types of condition or possibilities, and we're going to have some numerical problem to complying this example. Now let's have a summary. So summary for the nature of stationary point, the NSP. So we can write down the type of nature. We found 3 possibilities. So one is maximum, the second type will be minimum, and third one is inflection, right? Inflection. And how it's look like the shape, and we actually check by the second order derivative. So for maximum, it will be look like this one, and here is the stationary point. And for minimum, it will look like this, and here is the minimum point. And for inflection, the shape will be look like s, and the value of second derivative d square y dx square will be negative. It means that less than 0, and the second order derivative d square y dx square for minimum value, it will be positive. It means greater than 0. And the last one, the inflection type or the nature is inflection. It means that the second order differentiation d square y over dx square will be 0, right? If it is not 0, we have to, or maybe if it is 0, then we have to go for third order derivative. Thank you.